now let us look at the standard way of expanding our binomial theorem. As we've looked at this in our introductory lecture as well, x plus y to the power n can be opened up as nc0 x to the power n y to the power 0 plus nc1 x to the power n minus 1 y to the power 1 plus nc2 x to the power n minus 2 y to the power 2 plus, and this goes up till ncn x to the power 0 y to the power n. And I hope you all remember how we used to write down the general term, or how this entire thing can be written down as. This can be written down as r is equals to from 0 to n, and here it can be written down as ncr x to the power n minus r y to the power r. And this portion here, this is our general term. Now from here I hope you all can see that r is always either less than equal to n, or it is greater than equal to 0. So you must remember this concept as well. And now this general term that we are talking about, this is our t of r plus 1. So you must remember this thing as well. Now again, I am repeating the things because so that you all remember each and everything by heart. It is t r plus 1. So whatever the value of r is, a term that we are talking about is 1 greater than that. So now this was the expansion of x plus y to the power n. Now let us talk about what if I have x minus y to the power n. If I have x minus y to the power n, I can write this down as x plus minus y whole to the power n. And I can simply expand this in the way like I did this expansion. So how can I write this down? This can again be written down as nc0 x to the power n y to the power 0 plus nc1 x to the power n minus 1 minus y to the power 1 plus nc2 x to the power n minus 2 minus y to the power 2 plus, and this goes up till nc n minus 1 x to the power 1 y to the power n minus 1, sorry, this is not y, this is minus y to the power n minus 1, and the last term would be ncn x to the power 0, and here we would have minus y to the power n. Now from here, if I was to write down the general term of this entire equation, or let's say the entire summation in the summation format, how can I write it down? It can be written down as summation r equals to again 0 to n ncr, this remains the same, x to the power n minus r, this also remains same, and I can write this down as y to the power r and minus 1 to the power r. So this can be written down as minus 1 to the power r. Now of course, whenever r is an even number, minus 1 would become simply 1 and we would have a positive term there. And whenever r is equal to let's say any odd number, that time r minus 1 would remain minus 1 and that term would become negative. So that is how this type of terms are opened, and our general term for this type of equation, this portion, this would become our general term again. This is our general term, and again this is t r plus 1. So this is how standard expansion is done for any x plus y to the power n polynomial. Now again, repeating the same things, we know how we can write down our standard term. It is t of k plus 1 nck a to the power n minus k b to the power k. You can choose k or r, any variable you want. Here they have taken an example as well. Now let's talk about middle term. Now I hope you all remember that we had studied if we have a polynomial which is a plus b to the power n. So what would be the number of terms in this expansion? There would be n plus 1 terms in the expansion. I hope you all remember this. Now let's say if I have, of course, the middle term is going to be in the middle. So let's say if my n is even, if my n is even, that means my n plus 1 terms. That means I would have odd number of terms. If n is even, I have odd number of terms. And if I have odd number of terms, I can simply find out my middle term by n by 2 plus 1th term. This is how I can find out the middle term. So I hope you are understanding. Let's say if I have n is equals to 10, that means I have 11 terms in my expansion. And if I have 11 terms in my expansion, what would be my middle term? It would obviously be 6, because middle term is such that the number of terms on the right hand side and the number of terms on the left hand side both should be same. So if I have sixth term as my middle term, I have 5 terms this side, I have 5 terms that side. So that is why uh, we choose n by 2 plus 1th term to be our middle term. Now let's say if my n is odd, again there would be 2 middle terms, because now I would have even number of terms. Now let's say if my n was equal to 11, that means total number of terms in my expansion would be 12. And if I have 12 terms in my expansion, then of course there would be 2 numbers that would be lying in between, or 2 terms. So how can I find those 2 terms? It would be n plus 1 by 2th term and n plus 3 by 2th term. Now you must not confuse yourself with here we have n plus 1 in the numerator and 2 in the denominator. However, when our n was even, here we had n by 2, this was 1 term plus 1. So you must not confuse yourself with this. And again, they've shown us an example as well. If let's say if n is equal to 6, the middle term becomes 6 by 2 plus 1 4th term. And let's say if our n is 7, which is an odd number, so our middle terms become 4th term and the 5th term. So of course, now if I have 2 terms in between, that means the number of terms on the right hand side of these 2 terms and on the left hand side of these 2 terms would be same. So let's say if I have for example, let me take this example only. I would have 8 terms. So how can I write this? Let's say these are my 8 terms. 3, 4, 5, 6, 7, 8. Let's say these are my 8 terms. So my middle 2 terms, this would become my middle term. So now you can see that on the right hand side I have 3 terms, and on the left hand side also I have 3 terms. So that is why these 2 are considered as my middle term. Now talking about independent term or a constant term, of course, it would be such a term where there is no x variable, or let's say if I have in my expansion a plus b to the power n. So it would be such a term where the powers of a and b both become 0. That means I have no a and b in that equation. I would only have some constants in that value. So for example, let's say x plus 1 by x to the power n. Let us take this for an example. So if I have x plus 1 by x to the power n, how can I write down my general term for this? My general term can be written down as NCR x to the power n minus r and y to the power r. So what is my y here? It is my x, 1 by x to the power r. So let us simplify this further. This would become x to the power n minus r, and here below I would have x to the power r, and I can simply remove this x to the power r by taking the power sign in the power. So this would become NCR x to the power n minus r minus r. So here I would have NCR x to the power n minus 2r. So now if I have to find, let's say, my constant term, that means I have to make this term to be 0, or let's say this term to be 1. And when can I have x to the power something to be 1? When I have x to the power that something there is 0, whatever be the value of x. If any term it has its power to be 0, then that means the value of that term is 1. So I can say that n minus 2r needs to be 0 and n has to be 2r. So whenever n would be equal to 2r, that term would become free of x, and that would be my constant term or independent term of x. Now this happens only in certain cases. For example, this one. Now let's say if I had a plus b to the power n. So what would be my general term here? NCR a to the power n minus r and b to the power r. So here now I would have to say that for a and b to get removed from this entire equation, n minus r would have to be equal to 0 and r would also have to be equal to 0. Then only I can say that my term is independent or constant. So you have to keep that thing in mind. This is how independent term is found. Now let us talk about a few more things. Now let's say if I have, again, I'm taking the standard binomial expansion, which is my 1 plus x to the power n. Again, how can I expand this? This would expand as nc0 uh, plus nc1 x plus nc2 x square plus, and this goes up till ncn minus 1 x to the power n minus 1 plus ncn x to the power n. Or the general term for this entire equation can be written down as r is equals to 0 to n, and here we would, sorry, this is n, and here we would have ncr x to the power r. So this is how the general term is written for such type of expansion when we have 1 plus x to the power n. Now, of course, you must remember this because this is an important expansion. Mostly questions are asked based on this. So if you know this, this is our general term. Now, what can you tell about this entire expansion? What is my coefficient of my variable term at any time? So let's say if I have to find out the coefficient of x to the power r, so it is going to be ncr. So I'll write it down. You must remember this. Again, you can obviously find it out during the question as well, but if you remember it, it is going to be easy and faster for you to solve questions. So what am I saying is that, let's say if I have to find coefficient of x to the power r in this equation, it would always be ncr. So you must remember this. Sometimes what happens that in the question they might give you what would be the coefficient of x to the power 6 in this equation, of course in the expansion of this equation, sorry. So you can simply write it down as nc6 would be my expansion. So that is how this is done. Apart from this, let's say if I would have had 1 minus x to the power n, how would I expand this? This would open as nc0 minus nc1 x plus nc2 x square minus nc3 x cube, and this goes up till plus nc, or sorry, this would not be plus. We do not know what would be the sign. This would be x to the power n, and this would be minus 1 to the power n. So of course, any general term for this entire equation can be written down as r equal to 0 to n, ncr x to the power r, and this would become minus 1 to the power r. So this is how the general term for this type of expansion is written down. So you must remember this as well. This is our general term for this. Now let me tell you a few more things about ratio and binomial coefficients. That again, these are two main properties that you must remember. Of course, you can derive it during the exams as well. If there is a question asked based on such properties, you can derive those properties as well, but it is recommended that you remember it. So sometimes, let's say if you have to find out the ratio of ncr upon ncr minus 1, that means you have to find out the ratio of binomial coefficient of two consecutive terms. In the question, it would be given something like this, that you have to find out the ratio of two consecutive terms. So this is my ratio of two binomial coefficients consecutive terms. So how can I write this down? You can directly write this down as n minus r plus 1 upon r. This would be the ratio. If you were to look at the proof of this entire equation, first let me put this in a box so that you remember this. If I was to prove this entire equation, how can I write this down? My upper part of my numerator part, it would expand as n factorial upon r factorial, n minus r factorial, whole upon, this would be written down as n factorial upon r minus 1 factorial, n minus r plus 1, sorry, yes, this would be n minus r minus 1 factorial. So from here, of course, n factorial would cancel out, r minus 1 factorial would cancel this factorial out, and n minus r minus 1 factorial would simply cancel out this factorial as well. So from here, what would we be left with? We would be left with sorry, this would be n minus r minus 1. So let us open this up. What are we going to get? We are going to get n minus r plus 1 factorial upon, below we would have r into n minus r factorial. And now from here you can see that I can cancel n minus r factorial with this factorial, and I would be left with n minus r plus 1 upon r. So you must remember this. Again, if you do not remember, it is not a very big problem. You can derive it, obviously. It just takes less than 30 seconds for you to derive, but if you remember it, you can save those 30 seconds and apply it into the next question. So that is obviously the main motive of JEE Mains, to save time in each and every question so that you can apply it in the questions which are lengthy and tough. One more thing that we must remember is, let's say if we have NCR plus NCR minus 1. So how can I write this directly down? This would become N plus 1 CR. Again, another important thing, if I am finding out the sum of binomial coefficients of two consecutive terms, then it can be written as N plus 1 CR. Again, you can simply open it up in the this factorial format and find out the proof. It is very easy, but if you remember this, it is going to be very easy for you. So now let's look at a few questions based on expansion and how questions can be asked. The coefficient of x to the power 5 in the expansion of this. Again, a very easy question. You just simply have to write down the general term. You have to find out the powers of x and make that power of x to be 5. Whatever value of r you get by making it to 5, that would simply indicate what would be our coefficient of x to the power 5. So let us write down the general term for this entire expansion. What would be my t r plus 1 in this expansion? It would become NCR x to the power n minus r and y to the power r. So let us write this down. This becomes t r plus 1. This can be written, and my n value is 5 cr. Here instead of x I have 2x cube to the power 5 minus r, and instead of y I have minus 1 by 3 x square, or let me take the minus out, 1 by 3 x square to the power r minus 1 to the power r. So from here, let me take all the powers of x together and the x terms together so that I can find out what would be my coefficient of x to the power 5. So from here, what are the constant terms that we are getting? My constant terms are 5 cr. My constant term is minus 1 to the power r. And what else is my constant term? My constant term is 2 to the power 5 minus r. And my constant term is 1 by 3 to the power r. Now let us come to the x terms. What is my x terms going to be? First I would have x to the power 15 minus 3r upon x to the power 2r. So this would be my x term, and how can I write this down? This thing down as, this can be written down as x to the power 15 minus 3r minus 2r. So basically this means that it is x to the power 15 minus 5r. So this is my general term basically. So my general term becomes t r plus 1 to be 5 cr minus 1 to the power r, 2 to the power 5 minus r, or let me write this down here, and I have 1 by 3 to the power r, and here I have x to the power 15 minus 5r. So this is my general term for this entire equation. Now what have they told us? We have to find out the coefficient of x to the power 5. That means if I have to make my this value to be x to the power 5, how can I write it down? I have to say that 15 minus 5r should be equal to 5. From here, what would I get the value of 5r to be? This would become 10 and r would be equal to 2. That means for r equal to 2, I can find out my coefficient of x to the power 5. So whenever I'm writing r is equals to 2, this becomes rt3. Here I would have 5c2 minus 1 to the power 2, 2 to the power 5 minus 2, and I would have 1 by 3 to the power 2. And here I would be left with x to the power 5. So I have to find out the coefficient of x to the power 5. So basically this entire thing is my coefficient of x to the power 5. So let me find out the value. 5c2, how can I write it down? 5 into 4 by 2. We had learned the shortcut trick. Minus 1 square simply becomes 1. This can be written down as into 2 cube upon this becomes 3 square. So from here 2 gets cancelled out with this by 2, and from here what do we get our final answer to be? This becomes 80 by 9. So this becomes our answer. So this is how we find out the coefficient of any terms in the expansion. Again, very easy question, and these are the only type of questions if asked Like let's say if JEE asks directly a question from binomial theorem, then it is going to be of this level of hardness. So I hope you all can understand this is a very easy topic and how you can score from this topic. Let's look at another question. If in the coefficients of three consecutive terms in the expansion of 1 plus x to the power n are in the ratio 1:5:20, then the coefficient of fourth term is. Now, I hope you all can see that we have been given three consecutive terms and we have 1 plus x to the power n. So, first let us write down the general term for this. How can I write down the general term? It would be written as tr plus 1 is equals to ncr x to the power r. Simply this is how my general term would be written. And now they've told us that the consecutive coefficients of three consecutive terms. That means let me take tr plus 1 and tr plus 2. I can take these three to be my consecutive terms. I hope you are understanding how I'm choosing my consecutive terms. Now if I was to write down the, of course, the general term for all these three terms, I would be left with somewhat like this, and my coefficient of x to the power r at any time would be ncr. So let's say for t to tr, what would be my coefficient? It would be ncr minus 1. For tr plus 1, my coefficient would become ncr. For tr plus 2, my coefficient would become ncr plus 1. I hope you are understanding this. Now they've told us that these three are in the ratio 1:5:20. So let us take 2 at a time. That means I can say that NC R upon NC R minus 1. This is equal to 5/1. And I hope you all remember we had again studied the shortcut form of finding the value of NCR upon NCR minus 1. So this would become N minus R plus 1 upon R. This is equal to 5. So from here what do we get? N plus 1 is equal to 6R. So this is our first equation, we can say. Now let us find out the second equation by using these two terms. What do we get? NCR plus 1 upon NCR, and this value is equal to 5:20. So this becomes 20/5. That means this is 4. And how can we write this down as N minus, instead of R, what do we have here? We have R plus 1 at top. So this becomes R plus 1. N minus R plus 1 upon R plus 1. This is equal to 4. Now if I was to open this entire thing, this would become N minus R minus 1 plus 1 upon R plus 1 is equals to 4. From here, this and this gets cancelled out. We would have N minus 4 is equals to 5R. So this is my second equation that I'm getting. Now if I were to solve these two equations, if I, let's say, put the value of N to be 6R minus 1 in this equation, so what would I get? 6R minus 1 minus 4 is equals to 5R. From here, what do I get? My R to be equal to 5. If my R is 5, that means what would be my N's value? This is 25. 25 plus 4, N becomes 29. So now what have they asked us? They've asked us to find out the coefficient of fourth term. So that means my fourth term, this would become T3 plus 1. And so from here I can write down, we have to find out NC3, my N is 29, x to the power 3. Now they've told us to find out only the coefficient, so we will just find out the value of this. And how can we write down 29C3? It can be written down as 29 into 28 into 27 upon 3 into 2. So from here 3 gets cancelled out this by 9, 2 14s, and what do we get after multiplying all these values? We are going to get 3654 as our answer. So this is how questions are generally asked. Let's look at one more question about the middle term. The ratio of the coefficient of the middle term in the expansion of 1 plus x to the power 20 and the sum of the coefficients of two middle terms in the expansion of 1 plus x to the power 19 is. So basically, if we look at the first term, what do we have? 1 plus x to the power 20. That means my n here is even. That means I would have odd terms in the expansion. If I have odd terms, how can I write down the middle term? My middle term would be written down as n by 2 plus 1th term. So basically this would be my 11th term. So how can I find out my 11th term? Or first let us find out the middle term for this as well. Now here I have 1 plus x to the power 19. That means my n here is odd. That means I would have even number of terms in the expansion. And if I have even number of terms in the expansion, that means I would have basically two middle terms. And so from here I can say that my two middle terms would be n plus 1 by 2th term and n plus 3 by 2th term. So simply this would become my 10th term and 11th term. Now what have they told us? The ratio of coefficient of middle term in the expansion of this and the sum of coefficients of two middle terms in this. So basically we have to find out t 11th term for 1 plus x to the power 20 and divided by t10 plus t11. So, and we only have to find out the coefficient if let's say I was to find out the general term. So how can I write down the general term for this? This would be r equals to 0 up till n ncr x to the power r. So my coefficient is nothing but ncr. So I can write this down as, and for the first term my n is 20 c, r becomes 10 here, and here I would have 19 c 9 plus 19 c 10. I hope you are understanding. This is the terms in the denominator, they have the value of n to be 19, and the terms in the numerator, they have the value of n to be 20. So you must keep that in mind. Now I hope you all remember we had studied this inequality. NCR plus NCR minus 1, this value is equal to n plus 1 CR. So now I can apply this here below. So I would be left with 20C10 upon this would become 20C10 again. So from here this becomes 1 and this is our answer. So our ratio is 1. So this is how middle term and ratio questions are done. Let's look at this another note. Again, this is not something that you must remember, but this is just for your understanding. Let's say if I have x plus y to the power n plus x minus y to the power n. If I'm adding these two terms, I hope you all remember that in this term there used to be some negative terms. The general term for this used to be written in this format: ncr x to the power n minus r y to the power r minus 1 to the power r. So whenever r used to be an odd number, that time we used to get a negative term. So basically all those terms which used to be odd numbers, so nc1 nc3, they all have been removed, because of course they would cancel out amongst each other from this term. So that is why, and the sum of the rest of the terms would be twice, so it becomes 2 times nc0 x to the power n. So this is how the sum of first one is done. And let's say if I was to take out the subtraction, that means my negative terms would become positive and it would become twice, and all my positive terms would be removed. So this is how the summation is done. Now let's say if I was to take the more standard form, if I was to take 1 plus x to the power n plus 1 minus x to the power n. So how can I write this down? Again, it would be written in the same format. 2 times of this would become nc0 plus nc2 x square plus nc4 x to the power 4, and this goes up till ncn x to the power n. Now let's say if I was having 1 plus x to the power n minus 1 minus x to the power n. So now I would be left with only the odd r value terms. So this would become nc1 x plus nc3 x cube, and this goes on till the end. So this is how these two terms are written. Now again, this it is not necessary for you to remember this thing, but this is just for your understanding that how you can visualize without writing down both the general terms. You can simply just visualize how you can eliminate terms from an binomial expansion. Now let's look at this concept. Now this is another type of concept. Through the question we will try to learn this concept. We have to find out the number of integral terms in the expansion of this. So integral terms, of course, now you can see that the powers of this 3 to the power half, 5 to the power 1 by 4, these are basically irrational numbers. Now we have to make it first in the form of integer terms. That means the power of these two numbers should be a whole number, either a whole number or an integer. Of course, we wouldn't be having any negative terms at the power, so let us assume it would be a whole number only. So again, the concept remains the same. The only thing is that the way of solving this question becomes a little different. Let's say, again, I would simply write down the general term for this equation. How would I write this down? It would become 680 CR x to the power n minus r. What is my x here? 3 to the power half to the power n minus r. Sorry, n here is 680 minus r. And y to the power r. What is my y? 5 to the power 1 by 4 to the power r. So let us write this down in a more better way. 680 CR. And this becomes 3 to the power. This would become 340 minus r by 2. And this would become 5 to the power r by 4. Now they are telling us that we have to find out the number of integral terms. Now, of course, this value, whatever be the value of r, this is going to be an integer. At any time, this is going to be an integer. Or more than an integer, it is going to be a whole number. So we have to basically make these two terms, convert these two terms into our integer. So how can we convert this? Of course, the power of these two terms, 3 and 5, they should also be a whole number. If the power is a whole number, that means we can get an integer while solving it. So that means I'm saying that r by 4 must be equal to a whole number. And 340 minus r by 2, this also should be either a whole number or integer, both works. Again, let me write down integer only so that it becomes easier for you to understand. It should be an integer. Now when can I say that r by 4 would be an integer? When I have r which is multiples of 4. So r, I can say that r should be either 0 or 4 or 8 or 12 and goes on up till 680. 680 is also divisible by 4, so the end term. And these values of r, they would also satisfy this. So basically I have to find out the intersection of the values that satisfy this part and this part. So for here, again, r can be all those values of r that are satisfying r by 4. So basically my intersection would come out to be this only. I hope you are understanding this thing. We have to find out the intersection of values of r that are satisfy this equation as well as this equation. So here we have r by 4. So of course the values that would be satisfying this equation would ultimately satisfy this equation, because here we have r by 2. Any number divisible by 4 is divisible by 2. And of course, even if the power comes out to be negative, we do not care about that because we will get an integer term, right, at the end. So basically we've got the answer. That means the value of r can be these for us to get the integer value. So let us count how many terms are there. So here we have, basically this is an AP which goes up till 680 terms. This is our AP. So how did we used to write out the nth term for an AP? It used to be a plus n minus 1d. And what is our nth term here? 680 is equals to 0 plus n minus 1 into 4. And from here, what do we get our n value to be equal to? 171. So this becomes our answer. So for 171, there are going to be 171 integral terms in this entire expansion. 171 integral terms are going to be present in this entire expansion. So you must remember this. Now let's say if you were to check, let's say if I, in this equation, of course you must check in this equation only because there is a negative sign here. Let's say if I was to take the maximum value of r, that is 680. If I take r to be 680, what is it going to be? R by 2 would become 340. 340 minus 340 becomes 0. So again, it is an integer or a whole number that we are getting. So basically we've calculated all the integral terms that would be present. Now in the questions, what generally they can ask is, instead of integral term, they can say that find out the number of terms that are independent of the variable x, and they would give certain powers of x in the binomial expansion. They can also try to ask what would be the fractional part in the entire expansion of binomial equation. For fractional part and remainders, we will come into that. We will look at it in the further slides. But from this question, I hope you must have gotten an idea how we can solve the basic questions of binomial theorem.